In this video, we will review how to solve right triangles. We will pay special attention to sine, cosine, and tangent. Know these definitions. If you are looking at an angle in a right triangle, first of all, the hypotenuse is across from the 90-degree angle. Now, across from the angle you're looking at is called the opposite leg. Right next to the angle you're looking at is called the adjacent leg. Now, armed with those words, you can define sine, cosine, and tangent of the angle. Sine of the angle will be the opposite leg over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, to make it easier to remember, we will sometimes say, just use Sohcahtoa. And of course, that is the three definitions squeezed into one funny sounding word, where so stands for sine is opposite over hypotenuse, ca, that's cosine, is adjacent over hypotenuse, and toa, tangent, is opposite over adjacent. So if you can remember Sohcahtoa, then you can remember all of your definitions. Alright, we'll be using this triangle for everything on this page. So problem number 9, find the length of side US. So here's side US. I'm going to put an X right here to remind us. Okay, now there is an angle involved, so you can bet that we're going to wind up using Sohcahtoa. Okay, so let's see, Sohcahtoa. So let's label everything. Well, across from the 90 degrees is the hypotenuse. Let's circle the angle. Across from the angle that we circled is always the opposite leg. Right next to the angle is the adjacent leg. The opposite leg is doing nothing. There's no value here, and that's nothing that we're looking for, so throw it out. Sine involves opposite, throw it out. Tangent involves opposite, throw it out. So that's why we will be doing cosine. So we're going to go ahead and say the cosine of the angle we circled is equal to adjacent over hypotenuse. So that'll be 32 over x. When the variable is in the denominator, that's when you swap these. So we're going to go x is equal to 32 over cosine of 29. And this is something we can put in the calculator. Alright, 32 over the cosine of 29. So that is 36.587. Okay, number 10. Find the length of side ST. Alright, so here's side ST, so I'll put an X right here. Alright, nothing else is really moving, so I've still got the hypotenuse is over here across from the 90-degree angle. Across from the circled angle is going to be the opposite leg, and right next to it is still the adjacent leg. Okay, the hypotenuse is doing nothing on this problem. There's no value here, and there's no variable that we are looking for. So throw it out. Sine involves the hypotenuse, so throw it out. Cosine involves the hypotenuse, so throw it out. That's going to leave tangent. Tangent is opposite over adjacent. So we will wind up writing the equation tangent of the angle is equal to opposite over adjacent. So that'll be x over 32. Okay, when the variable is in the numerator, that's when you multiply both sides by the denominator. Alright, that way these will just cancel out and you have x by itself. So this will give you the answer, 32 tangent 29. Alright, you don't need parentheses or anything. Alright, you can just type that straight in your calculator. 32 tangent 29. Alright, that is 17.738. Got to round up. Alright, for number 11, we are to find the measure of angle S. Okay, well, this will not take very much work. We already have one angle given. So the other angle, it has to be complementary. Alright, these have to add up to 90. So I can find this angle by doing 90 minus the angle that I already have. So 90 minus 29. Alright, so that is 61. Okay, not a lot of work to show. Okay, number 12. When you have a double triangle like this, what you want to do is separate it into two triangles. So the triangle on the left, alright, can be drawn like this. Okay, so there's your 71. Here's that 52 degrees. Alright, here's your x. There's your 90-degree angle. So there's that. The triangle on the right can be redrawn. Okay, so there's your 58. And there's your y. And this x was shared between both triangles. So this will be x again right here. So only one of these triangles can be solved immediately. So you have to decide which one to do first. This one has two variables. This one only has one variable. So you definitely want to start by solving the triangle on the left. Okay, so let us change colors. Need some contrast here. So let's circle the angle and label the sides. So across from the 90-degree angle, you've got your hypotenuse. Across from the angle that you circled, you've got your opposite leg. And right next to the angle, you've got your adjacent leg. Now, let's look at Sohcahtoa. The opposite side is doing nothing. There's no value here, and there's no variable that we are looking for, so throw it out. Sine involves the opposite leg, so we got to throw that out. Tangent involves the opposite leg, so we got to throw that out. That leaves cosine. So that's why we will be doing cosine of the angle we circled. Okay, and cosine is adjacent over hypotenuse. That is x over 71. When the variable is in the numerator, you multiply. You multiply by the denominator. Okay, that way these cancel out. So over here we have 71 cosine 52. Okay, and that's going to give you the value of x. So we can just put that in the old calculator. 71 cosine 52. So that's 43.712. Got to round up. 43.712. Okay, now we can move on and solve the other triangle. Okay, but we now know what x is. We just found the value of x. So let's erase the variable x and replace it with what we now know it is. Okay, it is 43.712 approximately. Okay, so let's circle the angle that we've got and get to labeling. Across from the 90-degree angle is the hypotenuse. Across from the angle that we circled is the opposite leg. Right next to the angle that we circled is the adjacent leg. Which one of these sides is doing nothing? The adjacent leg is doing nothing. There's no number here, and there's no variable either. So when we consider Sohcahtoa, adjacent is doing nothing. So cosine involves adjacent, throw it out. Tangent involves adjacent, throw it out. That's how we know we will be doing the sine function. So sine of the angle we circled is equal to opposite over hypotenuse. So that'll be 43.712 over y. When the variable is in the denominator, you swap these. So we will have y is equal to 43.712 over sine of 58. And we can just put that in the calculator. Okay, so 43.712 over sine 58. Okay, so that is 51.544. Okay, a ladder that is 20 feet long leans against a wall and goes 18 feet up that wall. Okay, so let's see. Here's the ground. Here's a wall. Okay, and let's see. Here comes the ladder. All right, that's my ladder. So the ladder is 20 feet long. So the 20 goes here. Okay, it leans against a wall and goes 18 feet up that wall. Okay, so this is 18 feet. All right, this is 20 feet. Okay, what angle is formed between the ladder and the ground? So here's the ladder, here's the ground. So this is the angle between the ladder and the ground. So that's the picture. Obviously this is 90 degrees. So it's time to set it up. Let us circle the angle that we have, and let's label the sides. Well, across from the 90-degree angle is the hypotenuse. Across from the angle we circled is the opposite leg. Right next to the angle we circled is the adjacent leg. Okay, this involves an angle, so we will be using Sohcahtoa. Now, the adjacent leg is not doing anything, so we're going to throw it out. Alright, there's no number here, there's no variable that we're looking for. Cosine involves adjacent, so we're going to throw that out. Tangent involves adjacent, so we're going to throw that out. So we'll be using the sine function. Sine is opposite over hypotenuse, so we will say the sine of the angle is equal to opposite over hypotenuse, so 18 over 20. When the variable is inside the trig function, that's when you do the inverse trig function. So we will say x is equal to the inverse sine of 18 over 20. And we can just put that in the calculator. Okay, inverse sine of 18 over 20. Okay, that is going to be 64.158. Okay, a cable that is 180 feet long connects the top of a cell tower to a stake in the ground, forming a 65-degree angle. How tall is the tower? Let's see. Choose the diagram that's labeled correctly. Okay, so obviously this is the wire, this is the ground, and this is the tower. So we have a 180-foot long cable. So I'm looking for 180 to be here. So this is wrong immediately. This is wrong. Alright, really this is the only one that has even the cable in the right spot. Because I'm looking over here. That's wrong. Okay, so it must be this one. Let's look at the other pieces of information. So 180-foot cable. Okay, forming a 65-degree angle with the ground. So that's good. How tall is the tower? We have X on the tower. So C is the correct picture. Now, using that picture, we're going to find the value of X. So let's circle the angle and label the sides. Okay, so this is the angle. Across from the 90 degrees is the hypotenuse. Okay, now across from the angle that we circled will be the opposite leg. Right next to the angle that we circled is going to be the adjacent leg. Okay, so since we're dealing with an angle, you can bet we're going to be using Sohcahtoa. The adjacent leg is doing nothing. There's no number here, there's no variable we are looking for, so throw it out. Cosine involves the adjacent leg, throw it out. Tangent involves the adjacent leg, throw it out. That means we're going to be using the sine function. So we will say sine of the angle we circled is equal to opposite over hypotenuse. So that'll be x over 180. When the variable is in the numerator, that is when you multiply both sides by the denominator. Alright, that way these will cancel each other out. Alright, so this will give you the answer, and you can just put that in your calculator. 180 sine 65. Okay, so that's going to be 163.135. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.